Yes, have you informed to others? Sukriti, are you there?
Yes, ma'am.
So have you informed to everyone to join the class today?
Yes, ma'am, I've informed.
Okay. Okay, so can we start it now? Others will join later if they want. Fine. So this is module number 5. We are working on module number 5 and this is memory testing. So पिछली क्लास में क्या पढ़ा था हमने? What we have covered in last classes?
Bingo.
BILBO and problems applications.
Yes, BILBO, and before that we have BIST architectures we were using. Okay, so for memory, actually design and the testing and verification, everything is a little bit different for memory. Okay, so that BIST was for general type of CUTs, maybe combination circuits or sequential circuits, whatever it was. So that was the BIST architecture. Here for memory testing, we have to find out what type of architectures do we need. Okay, so first introduction for memory testing, then memory architecture, fault models, testing algorithms, AC/DC dynamic test, built-in self-testing schemes, and built-in self-repair. All these are the topics related to this. So why we go for the memory? So this is actually the market share for the memory is given DRAM, flash and ROM, SRAM. So DRAM कहाँ पर काम में आती है आपके कंप्यूटर आर्किटेक्चर में? कुछ आइडिया है? SRAM is the fast memory which is used in cache, and this is actually in the main memory because dynamic is DRAM is a little bit slow, but the density is really very high. Okay, flash memory is very fast memory. Generally ये A to D converters and all this में काम में आती है. ROM is actually read only memory, so special functions में जिनको एक बार करके और भूल जाना है क्योंकि वो वैसा ही काम करेगा, so for that it will be used. So these are four types of memory and these applications of this. So DRAM price per bit. This is given for the price per bit for DRAM. So you can see the DRAM price per bit is going to decrease day by day, day by day. In 91, it was dollar 400 per megabit, and in 99 it was 0.1 to 0.3 dollars per megabits. And nowadays you can see, in fact, in $2 to $3 you can purchase so much of gigabits, है ना? गीगाबिट्स में आ रही है ना? योर पेन ड्राइव इज जीबी, राइट? एमबी में कुछ आती है क्या पेन ड्राइव आज की डेट में?
No, ma'am.
No, right? Not even RAM, not even nothing comes in MB nowadays. Earlier days it was MB. Generally, अगर आपको किसी को याद हो या आपके पेरेंट्स को याद होगा, फ्लॉपी डिस्क वाज ए मैग्नेटिक डिवाइस जो कि बहुत छोटा होता था, एंड करस्पॉन्डिंगली जो आपके P1 P2 P3 कंप्यूटर्स होते थे उसमें फ्लॉपी डिस्क का एक ऑप्शन आता था, एक अलग से फ्लॉपी ड्राइवर आता था. सो यू नीड टू इंसर्ट दैट इनसाइड एंड देन यू हैव टू प्ले इट. सो इट्स कैपेसिटी वाज अप्रोक्सीमेटली सम मेगाबाइट्स, राइट? जो सीडी होती थी, सीडी वाज लेस देन 1 गीगाबाइट, मीन्स 900 मेगाबाइट्स और लाइक दैट. सीडी, डीवीडी इसका थोड़ा डबल साइड होता था क्योंकि वो डबल साइड ट्रैक्स रखती थी, ऑप्टिकल रीडर से उसका होता था. floppy was magnetic based, and nowadays whatever memory you will be having, that is actually बेस्ड ऑन योर VLSI. ठीक है? इसलिए आपका पेन ड्राइव and SSD hard disks and all, you can find these in compact sizes, and these are really very cheap because of the mass production. ठीक है? If you want to
Yes, ma'am.
run your old computers a little bit more smoothly, what do? You will go for a RAM extension के लिए जाएंगे आप. ठीक है? So RAM also you can purchase from the market. It is going to increase the speed because it is going to increase the cache memory of the device. Test time as a function of memory. So this is the test time given as a function of memory. If the memory size is big, how the test time will take place. So testing time, there are actually different algorithms. So this is the timing complexity. Some of the algorithms might be proportional to the number of bits square of it. Some might be having the logarithmic and linear. Some might be having some linear only. So this is the size n, and depending on this size, these are the testing times. So you can see the testing times. So it depends on the algorithm how the testing time is going to take place. So in this case 64 megabits of memory is 584 days. इतने दिन में तो टेक्नोलॉजी दूसरी आ जाती है. So that's not actually market friendly. Okay, so this is a simple architecture of DRAM chip, dynamic random access memory chip. Uska architecture is given to you. You have the address bar, address latch is there. Then the address latch will go to the column decoder and row decoder because the main memory is like this. So in this you are having a set of columns and set of rows. So the complete address will be some part of this given to this and some part of this given to the row. And that's how the particular byte or particular space of the memory you can access. Generally, the main memory in earlier days, it was actually word by word. वर्ड मीन्स 8 बिट्स ऑल टुगेदर. सो 8 बिट्स जहां पर स्टोर होते थे उसका एड्रेस वाज डिफाइंड बाय दिस एंड दिस column decoder and row decoder. So that's why the column decoder and row decoders are there. Then you have a refresh logic, and this is the memory cell array, which is nothing but this, where you are going to target through these two. And then in the memory, actually you need to write also, you need to read also. So all this is there. This is to read. Sense amplifiers are going to sense what was the memory. Then this will be given to the data register so that it can read it. And the data register is having two type of things. One is the data out and one is data in. So if you want to write the data, you will be using the data in mode, and then it will go to the write driver, and then this is going to write to the memory. So this is how the DRAM is going to take place. Different fault models. So you have these fault models in the memory devices. First one is stacked fault, stacked 0 or stacked 1. Another one is the transition fault. When it is going to change from 0 to 1 0, then there can be a fault. Another one is the coupling fault. Coupling fault means, let's say there are two bits all together stored in the memory. This is 0 and this is 1. Let's say you are making it 1, so automatically this is going to become 0 and vice versa. So this is known as coupling fault. Means both of the bits, even if these are not intended to change, then also these are changing in couple. NPSF, neighborhood pattern sensitive fault, and the last one is address decoding fault. So these are the 5 fault models for the memory. So first we will start with stuck at fault. So stuck at can be stuck at 0 fault or stuck at 1 fault. It can be anywhere. Transition fault, when the bit is going to change from 0 to 1 or 1 to 0. Coupling fault, when the second cell's contents will automatically change when you are going to write in a cell. So neighborhood pattern sensitive, the content of the cell over the ability to change its contents, it influenced by the contents of some other neighborhood cells in the memory. So that is the neighborhood sensitive fault. Address decoder fault, any fault that affects address decoder is called as address decoder fault. For example, with a certain address no cell will be accessed, and a certain cell is never accessed. A certain address is accessing multiple cells. A certain cell can be accessed by multiple addresses. So these are the address decoder faults. 4 types of faults. First one is the address not accessing at all or accessing multiple cells. A cell is not accessed at all or accessed by multiple addresses. So there are 4 categories of the address decoder fault. Any questions so far? अभी तक कोई क्वेश्चन है क्या?
No,
Are you
ma'am.
there? Can you listen? Okay. Memory chip test algorithms. So memory chip test algorithms may have traditional test for stuck transition coupling faults, and test for NPS faults. So traditional test may, these are the traditional test algorithms. 0, 1. Test length is 4 times of the number of bits, and the time complexity is ON, means linearly depending on the number of bits. So the number of bits are N, so linearly the time will depend. Checkerboard, complexities and linear. Test length is 2 square. So here the complexity is quadratic. Is root n. So lesser than butterfly. Here you can see low. So it is greater than this bits of the memory complexities of the traditional test. March test. March test is a type of test. So how the algorithm will be working. First of all, if you want to write, you want to read, how you'll be doing. So first one is write 0. In the March test, what you are going to do, you are reading, writing, reading. This you will do. March means to process, to flow, right? Chalna. So you'll make 0, then you will read it. You'll make 1, then you'll read it. And likewise, you will keep doing on. So write 0 with up addressing order. Then in next step, you have to read that 0 and then you have to write 1 with up addressing mode. Okay, up addressing mode means one after other, all the addresses you will keep on writing. Then you have to read 1 and write 0 with down addressing mode. Read 0 with the down addressing mode. So in this fashion, you are going to read and you are going to write. You are going to read 0, write 0, read 1, write 1 with up addressing and down addressing. So this is the algorithm march test. Now, March algorithm, this is how you can denote upside. This means upside address 0 to address n minus 1. This is downside address n minus 1 to 0 side downside. This is both ways. So this is how you'll be writing. W0 means you have to write 0. W1 means you are going to write 1. Read 0. R0 means read a cell whose value should be 0. Read a cell whose value should be 1. जो आपने 0 लिखा था, you are going to read with R0 and you are going to read with R1. The one written by the W mode, right mode. So this is how the March algorithm. Modified algorithmic test sequence is one of the March algorithm methods. So this is written over here. You have to write W0, write 0 in both sides, upside and downside. Then you have to read 0 and write 1 in both side, upside and downside. And read this one, both side, upside and downside. So this is how the algorithm is. I hope you understood with the help of the notations. समझ में आ गया? Type Y if yes, type N if no.
And could you please repeat what this upside and downside means?
Hmm. Look, memory is somewhat like this. Let's say the address content is 0 here, 1 here, 2 here, 3 here, 4 here, and like that. So upside and downside means you are writing here, then here, then here, then here. Means one after other, you will keep on writing in this fashion. So this is downside. Okay, write downside and then read downside 0. You have written 0 downside, so you'll be writing and then reading, right? So this is how you will be reading it. All zeros will be read with the same sequence. Then this is bidirectional. So once you have written in this fashion, then again you have to write zeros in this fashion and you have to read. Okay, so with the help of this, what exactly you are going to do? You are writing 0 in the forward way also and you are reading 0 in the backward way also. Okay, it is somewhat like that sometimes you might have seen some of the roads are like one way road only. So while going you have to choose other path, while coming you have to choose other path. So it might be possible there was there was a danger when you are coming back. So going forward was no danger, but when you are coming back there was a danger. So it means that is going to create a problem. So that's why this is taken in both of the ways, so that it can be identified well that there is no error when you are writing. The pattern is written in the like increasing order of the addresses or decreasing order of the addresses. Okay, so that's why you have to write in both ways. You have to read both ways. You have to write 0 in both ways, increasing order and decreasing order of the memory. You have to write 1 for the increasing order and decreasing order of the memory in both ways. And same thing you have to read in the same sequence so that you can identify that there was no problem. Yes, understood?
Yeah, ma'am, got it.
Okay. Others, if you understood, please type Y. Otherwise, if you want to ask something, please type N. So I hope it is understood by everyone. So let's proceed now. Okay. So in the first one, in the notational form, the algorithm is represented, and the same is represented stepwise. First step, what you have to do, write 0 to all cells in the forward way and backward way. For each cell, you have to read 0 in the forward way and backward way, and then write 1 in forward way and backward way. Okay, and read 1 from all the cells in both of the ways, and then your job is done. So this is the modified algorithmic test sequence for March test. So these are other March test algorithms. So these are in the notational format given. So this is the MATS algorithm, MATS plus plus algorithm. In MATS plus plus algorithm, you are going to write in both ways. Then one direction you are going to read, upside direction, downside direction you are going to read one. Marching 1 to 0, 1 to 0 marching. So you are taking, see, you are reading 0, then writing 1. In the same cycle, you are going to read 1. Then downside, you are reading 1, which was written earlier over here. So with the help of this read 1 and this read 1, the read is taken in both ways. Okay, and with the help of this, the read 0 is taken in both ways. So this is similar to your MATS algorithm. Okay, and likewise for W1, you will be bidirectionally, you will be writing, then you will be reading unidirectionally. First, you will be reading 1, then writing 0 and reading 0. Then downside, you will be reading 0, writing 1, and again reading 1. So March X, March C, March plus Mats plus plus, March 1 to 0. These are the different March test algorithms. So you can recall the names, and at least 2 to 3 of these you have to remember. These are other algorithms related to the March test. So test for stochastic transition and coupling faults. These are the algorithms. So these are all March test algorithms, and it is shown over here how much test length you can have. This is the test length, and this is the fault coverage. This is the fault coverage given, how much faults can be. So stochastic faults, transition faults, coupling faults, those can be covered with the help of this. For example, MATS algorithm, stochastic faults you can have, and with the help of marching 1 to 0, so you can have transition faults because it detects 1 to 0, 1 down to 0, it can detect. So this you can also have. March X, you can have some of the coupling faults also. So March X algorithm, let us check it. Yeah, this is the Martex algorithm. So with the Martex algorithm, stochastic faults, coupling faults, and some of the coupling faults and the transition faults you can detect. Okay, so the transition faults you can detect because you are going from 1 to 0 and 0 to 1, and coupling faults can also be detected with the Martex test. Now it comes NPSF. NPSF is neighborhood pattern sensitive fault. So neighborhood pattern sensitive fault means first thing is there is a cell and its neighborhood, and whatever pattern is there, the cells surrounding, means that particular cell, depending on the pattern in the surrounding cells, it can occupy one particular stacked fault. Okay, so that's why we call this as neighborhood pattern sensitive. Here 9 cells are given. So every cell is having n and n in bits. N can be 0 or 1, whatever. And this is base cell. So what it says is the neighborhood cells, which are denoted by n. If you are having a particular pattern, let's say this is a pattern, 3 plus 3 plus this is a pattern of these sets. If this is a pattern, automatically your b becomes, let's say, 1. You wanted that b was expected to be 0, let's say. These all are 1 1 1 0 1 1 1 and 0. So if this is the pattern, this becomes 1, but you want it 0. So this is actually a fault. Okay, why it happens? Because this memory is made up of semiconductor materials, maybe MOS, CMOS, and like that. So it might be possible there is a cross coupling, or maybe there is some types of coupling, and the total effect of all the individual cells is in such a way that this is going to change its value to a equivalent to a stacked fault for a particular pattern. It is not always stuck at 1. If the pattern is going to change, let's say I'm making it 0, so it might be possible that it is going to become 0 if you want to make it 0. So that's why we call this as pattern sensitive fault, neighborhood pattern sensitive fault. समझ में आ गया? Yeah.
Yes, ma'am.
Okay. Now there are different types of neighborhood pattern sensitive faults. The very first type is active neighborhood pattern sensitive fault. Active neighborhood pattern sensitive fault is like that. As n will be changing, b is going to be changed. And change हुए, n means the neighborhood bits cells. These are going to change. Let's say n is changing from 0 to 1, b is going to change from 1 to 0, or vice versa. So this is depending on the activity of the neighboring cells. Okay. Another one is passive neighborhood pattern sensitive fault. So passive means contain n patterns, b cannot change. So if n is all zeros, so b is stuck at 0 or 1. This is not going to change. Okay. Static neighborhood pattern sensitive fault. Here b is forced to contain a certain value. B is forced to contain a certain value. For example, all n's are having all ones. So B is forced to be 1 because surroundings are 1 1 1, and these, because of the cross coupling or something else, these are forcing it to be 1. So these are three types of neighborhood sensitive faults for the memory. Got it? Yeah.
Ma'am, active neighborhood pattern sensitive fault will take place when any one of the neighbor cells changes its value, or all of them will change the value.
Only the base cell is going to change the value. The base cell is the one which is going to change the value. All others are not changing the value.
So the neighboring cells n will remain constant.
Your voice is not clear. Can you type the question? Neighbors n will remain constant. No, whatever pattern we are thinking, according to that pattern, जब भी आप उस memory में वो pattern डालेंगे, memory means, see, memory means all these are the elements of the memory. All these neighboring bits are the elements of memory. So let's say you want to save some certain pattern. As I told you, 110 110. So this is what you want to store, and let's assume that depending on this particular pattern, this b base bit automatically goes to 1. Let's say I wanted to save 0 for this bit b, but automatically if in surroundings it sees such type of pattern, automatically it goes to 0, but I wanted to make it 1. Okay, so it is the pattern sensitive. It depends on the pattern how it is going to change. Another thing, it can be possible that, let's say, this is the set of neighboring bits is going from 1 to 0. So I wanted to store here 1. It is also getting changed from 1 to 0 or 0 to 1. So that is the active neighborhood pattern sensitive. Means depending on the activity of the neighboring cells. it is going to change. Base cell is going to change its value, which is not good. Yes, got it.
Yes, ma'am.
Clear to everyone? Is it clear to everyone?
Yes, ma'am.
So these were the different types of faults. DC parametric testing now. Open circuit, short circuit testing, power consumption testing, leakage testing, threshold testing, output drive current test, output short circuit drive current and short circuit current test. So these are the DC parametric testing we'll be doing for the memory. Okay, so we'll be doing the open circuit and short circuit, how the output is going to come, how much is the power is consumed, how much is the leakage power, how much is the threshold power, so leakage current, and how much is the threshold voltage, threshold value. All these things we'll be doing it. This is called as DC parametric testing, because here there is nothing related to the frequency. AC parametric sensing. AC means alternating current. AC, jo, the word meaning of the AC is alternating current. So in AC parametric testing, the output signal rise and fall times you have to figure out. Okay, you will be test for rise time and fall time of the signals. Relationship between input signals, how much is the setup time, how much is the hold time. What is the setup time and hold time? Let me make it clear if you don't know. This is a D flip flop, this is the clock. Clock flip flop is working at the active age of the clock. So if let's say this was the active age of the clock, so this is the tick where it is expected to sample your input. Let's say this was your input Q and this was your output Q. So the Q output will be taken the sample of input over here at this stage. So what you are expected at least sometime before this age and sometime after this age, your input has to be constant, and the time before the expected time before which your input is expected to be constant, you call this as setup time, and the time after which this is constant, you will be calling this as hold time. This time from this to this is the hold time. So this is how the setup time and hold time will take place. Okay, so you have to do find the relationship between setup and hold time. Relationship between input and output signals means how much delay and excess times have been there. For example, this Q will not be at the same age, but it will be delayed by the time period taken by the delay flip flop. D means it is the delay. D means the delay. So it is whatever has been sampled that will be visible at the output after some time. So that is the delay of the flip flop, or is original delay of the flip flop. Successive relationship between input output signals. This is going to test the speed of the test. डायनेमिक फोल्ड्स में क्या क्या आता है आपका? रिकवरी फोल्ड्स, सेंस एम्पलीफायर रिकवरी, राइट रिकवरी, रिटेंशन फोल्ड्स, स्लीपिंग सिकनेस, रिफ्रेश लाइन स्टकेट, static data loss. These are the different dynamic faults. And bit line precharge, voltage imbalance faults. So dynamic, as the name suggests, dynamic means generally हमारा जो DRAM होता है, डायनेमिक रैंडम एक्सेस मेमोरी, एज द नेम सजेस्ट, इन दैट विल बी हैविंग, सी वी हैव द सेंस एम्पलीफायर्स देयर. ठीक है, अभी दिखाया था मेमोरी का स्ट्रक्चर, DRAM मेमोरी स्ट्रक्चर. वी हैड सेंस एम्पलीफायर्स. दिस विल बी टेकिंग द डेटा फ्रॉम द मेमोरी which was selected from the address decoders. These are the address decoders: row decoder, RDC, column decoder, and this was your cell, memory cell. So every memory cell's output will go to the sense amplifiers, SA sense amplifier, and then the write recovery. So if something is written, then that will be read out through the sense amplifiers. Retention faults, sleeping sickness. Sleeping sickness, rephrase line static data loss. These are the retention faults. So sleeping sickness is what? Sleeping sickness is somewhat like this. See, this memory, DRAM memory, basic cell is depending on your capacitors. This is somewhat like this. You have a capacitor, then you are going to charge it in this way. This is going to be charged in this way. This is the capacitor, this is also a capacitor. So through the capacitors it is going to be charged. So this is a capacitor, then this is getting charged, and this is going to provide a resistance. So there is RC complete circuit. So it might be possible over a period of time when the device is going to sleep, to be in the sleep mode, जब आप inactive रह रहे हैं मेमोरी को, जैसे आपने just locked your system and you made it off. ठीक है. सो इवन इफ यू हैव लॉक्ड इट एंड मेड इट ऑफ, सिस्टम को शट डाउन कर दिया, तब भी मान लीजिए आपने अपना फोन या लैपटॉप चार्ज करके रखा, एंड इसको आपने 2 महीने बाद निकाला, the charge was full, but after that time you will be able to see that the battery is no more. So why it is going to happen? Because some of the cells are active in the sleeping mode also. So same thing happens with the memory. It might be possible that some of the cells are getting discharged through the RC. Because of that, you will be having the fault. Agar data 1 tha, that has gone to zero out like that. Rephrase line is stuck at faults. Rephrase line, as I told you, DRAM has these type of capacitors. So these are rephrased at time to time. Okay. So rephrase line is stuck at fault means you wanted to rephrase the data. So generally these are pre-charged to VDD by 2 to restore the data. So instead of VDD by 2, let's say it has stuck to either VDD or 0. So then this is going to create a problem. Static data loss. Static data loss means the data was either 1 or 0, and then now because of this it is not getting the correct output. So these are the retention faults. Bit line pre-charge voltage imbalance faults. So bit line pre-charge means you have to pre-charge the capacitors up to VDD by 2. So imbalance means there are two sets of capacitors. One is this side, one is this side. Both are expected to be VDD by 2. But if these are not, instead of VDD by 2, there is imbalance. Then because of that imbalance, the bit to be written will be a little bit different. Okay, so that is also going to create a fault, and these all will come under the dynamic faults. What are the pros and cons of built-in self-test? So there are some advantages. Minimal use of testers. It can be used for embedded RAMs. Embedded RAMs are the RAMs which you cannot visualize. These are inside your processor. So these are good for embedded RAMs. Disadvantages, of course, the silicon overhead area, the speed and slow access time, extra pins and multiplexing is needed. Testability of test hardware itself is also needed. High fault coverage is also a challenge. So the best advantages and disadvantages. Disadvantages are more like whatever the normal based operations were for the memory as well. So for memory, this is the typical BIST architecture using Mentor's architecture. So this architecture was taken by Mentor company. So that's why their name is Mentor's architecture. This is the memory module. Then algo-based pattern generator. This is the same thing. You will be having compressor. Here you will be having the data. Here you are having the address lines and all, and this complete is actually your best circuitry. Whatever is extra than the memory, that is the best circuitry. Okay, so it is similar to that what we have discussed earlier, that you have a test pattern generator, then CUT, and then ORA, logic analyzer, output response logic analyzer. So in instead of CUT you are having the memory module now. So because of the memory module, the test pattern generator is not only having the test pattern, but it also has a set of uh, address and the data to be accessed. Okay, and similarly the same thing will go to the compressor in order to identify that where the test is going on, whether it is completely fine or some problem is there or what. So this is equivalent to your ORA, output response analyzer, and compressor, as I told you, compaction and compression techniques of like a signature analyzer, parity checking, and all number count of ones and all. So any one of the compression technique will be taken into consideration, and the BIST circuitry is, this is the BIST circuitry. Okay. Multiple memory based architecture. So here in the multiple memory based architecture, so memory modules will be more, as we have done the same thing with multiple CUTs. So here the BIST is one, but the memory modules are more. And for all these memory modules, you will be having one BIST. For example, let's say in your system, you are having 4 RAMs. In earlier days, actually, 2 RAMs they used to give 256 and 256 KB. So in order to make 4 RAMs, you have to make that 4. Okay, they will be going to provide the slots. So all those will be accessed by one BIST circuitry, so that whenever you are using that particular block, then that is also connected with the BIST, and there is no need to have a separate BIST for that. So this is the multiple memory module BIST architecture. Serial testing of embedded RAM is also given over here. You can just check it. In serial testing embedded RAM, you are having some multiplexers and RAM is here. And this is the BIST controller block. So it is going to control all the things. And this is how it will be working. ठीक है, इसका हो गया है मेमोरी एंड बिस्ट आर्किटेक्चर्स. अभी जो कुछ बचा है विल बी डिस्कसिंग दैट डे आफ्टर टुमारो. ठीक है, नॉट डे आफ्टर टुमारो, ट्यूसडे. ठीक है, कुछ बच गया है उसको ट्यूसडे को लेंगे. सो नाउ व्हाट यू हैव टू डू. अभी तक कुछ समझ में नहीं आया, प्लीज आस्क.
Ma'am, do we need to remember these all architectures? I mean,
आर्किटेक्चर्स तो आपको याद करने ही हैं. दीज आर सिंपल आर्किटेक्चर्स, इनको याद करना है आर्किटेक्चर्स को. लाइक मेमोरी, single memory based architecture and multiple memory based architectures. So this is nothing like that. इसको CUT की जगह याद कर लीजिए. This is nothing but TPG. This is nothing but the output response analyzer. So same block. But since this is memory, so you'll be having the extra things like data, address, and all these things. So those you need to put. That's it. And in the next one, there are multiple blocks. So most of the signals will remain same, and others you will be having like this. Okay, so in the ROM only, since this is just read only memory, इसीलिए आपको सिर्फ एड्रेस मिला है, डेटा राइट का नहीं मिला है आपको. Right, output means every data is read at the output, so that's why the output is data only. Yeah, so these are simple architectures only. I think you should remember these. When you will be doing these by hand, you will be able to know these architectures. Easy है, ठीक है. So now let us discuss what suitable time you can have tomorrow. कल कितने बजे आप लोग आ सकते हैं? First EC1 batch and 5 students from EC2 batch I need tomorrow. प्रेजेंटेशन के लिए प्रेजेंट सभी को रहना है. Yes, tell me the suitable time, that at what time you can be available. Most of you have submitted the assignment too, so बाकी जो बचे हुए हैं वो भी assignment submit कर दो.
Ma'am, what about topics of assignment? I mean, topics of presentation.
कैन यू रिपीट, क्या बोल रहे हो?
Ma'am, you haven't allotted topics of presentation.
हाँ, टॉपिक्स मैं आज फ्लोट कर दूंगी, आज शाम तक मैं फ्लोट कर दूंगी टॉपिक्स. EC1 कंप्लीट, नमन, एंड 5 स्टूडेंट्स फ्रॉम EC2 बैच. That I will ask, क्योंकि here this is online presentation, so if I'm asking in the group, then it will be difficult for you to present in the class. I can call all the 5 students and to present, so that can be easy for me. But here, since it is online, so joint presentation will be a little bit difficult for all of us, सुनने वालों के लिए भी और बोलने वालों के लिए भी. सो कल 12 बजे का टाइम ठीक है क्या? 12 से 2 का टाइम, 12 to 2.
लंच करना पड़ता है बीच में.
हॉस्टल में रह रहे हो?
यस मैम.
तो 11 से 1 कर ले.
मैम 12:30 से 2:30.
नहीं, वो लंच का टाइम बता रहे हैं ना, 12:30 तो शुरू ही होता है लंच.
12 स्टार्ट हो जाता है.
12 शुरू हो जाता है.
नो मैम, 12:30 स्टार्ट होता है, अब लेट होता है.
जल्दी करवा
12:30.
दूंगा मैं.
बाकी हॉस्टल्स में दिक्कत आएगी. 10 से 12 का क्या
मैम
विचार है?
सब और विंडो में रहते हैं बॉयज तो.
10 से 12 का क्या विचार है? 10 to 12
हाँ मैम, 10 to 12 ठीक है.
सबके लिए ठीक है?
यस मैम.
ओके, सो लेट्स मीट. मुदित बोल रहा है कि उसके लिए ठीक नहीं है, तो मुदित एक दिन तो ऐसा कष्ट करना ही पड़ेगा आपको जल्दी उठने का. जल्दी खत्म हो जाएगा तो मैं आपके एक आध लेक्चर कोई बाद में बचेंगे वो छोड़ दूंगी, ठीक है? नेक्स्ट वीक अपने पास है ना, सो इन नेक्स्ट वीक एक आध लेक्चर जो आपका एक्स्ट्रा बचेगा वो मैं छोड़ दूंगी अगर जल्दी हो जाएगा तो. डोंट वरी, दिस 2 hours आई विल बी काउंटिंग, काउंट कर लूंगी मैं. डोंट वरी अबाउट दैट, ठीक है? यस, सो 10 to 12 let's gather at 10 a.m. and I will be floating the topics. जो भी बच्चे हैं उनको सभी के टॉपिक्स में, कल 30 बच्चे आएंगे तो 30 के टॉपिक्स में आई विल बी फ्लोटिंग. कैन वी हैव डे आफ्टर टुमारो ऑल्सो अनदर 2 hours? क्योंकि आई वांट, अगर ये जल्दी फिनिश हो जाता है तो सभी के लिए अच्छा है. मेरा भी दूसरा बैच आ रहा है 27 से, एंड ऑलरेडी फर्स्ट सेमेस्टर इज गोइंग ऑन. उनका एक्चुअली थोड़ा स्क्वीज करके जल्दी निपटाना है. अभी सेमेस्टर छोटा बना दिया गया है, उनको ज्यादा लोड रहता है वीक में. So if you want, I can take another 2 hours on this Sunday as well. Otherwise, it's up to you. I will be taking in the normal class, during the normal class. So normal class आपकी हमेशा 9 to 11 होती है, तो उसमें कम बच्चे आ पाते हैं. So that was the reason. ओके, आप ऐसा करना, CR से डिस्कस कर लेना. सुकृति, यू कैन टेल मी. सुकृति, कैन यू टेक द लीड?
Okay, ma'am.
And tomorrow, let's gather at 10 a.m. Okay. So be present. First 30 students, you revise all your fundamentals related to the topics given, and I will be floating the topic till evening today. आज इवनिंग तक मैं टॉपिक फ्लोट कर दूंगी, तो उस टॉपिक पर आपको बोलना है, ठीक है? बाकी आपको पढ़ने तो सारे ही हैं, एक बार रिवाइज कर लेना अपने अपने, ठीक है? Okay, thank you so much. Let's stop for the day. Have a nice
थैंक
day.
यू मैम.
Bye.
Thank you, ma'am.
Yeah, bye bye.